Hello, everyone, and welcome to the Adafruit Show and Tell. I'm Liz. I'm going to be your host this evening. If you would like to join the stream and share what you've been working on, you can find a link to join in the live broadcast chat on Discord, and our Discord server is at adafruit.it/Discord. First, though, we're going to hear from our very own John Park, see what he's been working on.
Hey, how you doing, Liz?
Good. How are you?
Good. I've been diving into the world of platform shoes.
All right.
And I mentioned this last couple of weeks as I was working on some WLED projects, but it was all sort of theoretical. I was putting LEDs into some little Pelican cases, like clear boxes to test the concept. But the whole idea came from a friend of mine who is a drag artist and wears platform heels both for pole, just for dancing, catwalk kind of stuff, as well as doing some aerial circus stuff. Sweet. And they made a comment to me, hey, I would love to do LED shoes that sync up to each other. And so what I've got here, this is one kind of platform shoe that has a mostly hollow platform here. There's actually a little bit of the heel that's up here that's also hollow. This one has a big support down the middle for weight bearing. And what I've done is used a heat gun and a spudger and pulled it open just so we can see
nice.
what we have to work with there. There's also another plastic plate up here, I think, to also help with some of the weight distribution. But it is a pretty nice open space. And the benefit of this particular model is it does come in some larger sizes, which my friend Josh wears. So I'm working with these, and I'll show you where I've gotten to in a moment with those, but I wanted to show you the original concept, and we just can't find these in the right size, is this style that has a little trap door in it, which is pretty cool. Originally,
that's very clever.
What I think these started out as was there was a little slot groove cut here by the manufacturer, and some of them said tips. And so feed dollar bills or fives or tens or hundreds, depending on how great a dancer you are. Your audience could feed in money. And I think those used this trapdoor to retrieve your cash at the end of the performance. The evolution of this is they realized people just wanted to put stuff in there, like glitter or reindeer heads or who knows what. But depending on the show you're doing and the costume you're doing, you've got this nice little access here. There is almost an entire platform there for weight bearing, and there's just this oval hole cut there. So one nice thing about this, and I am going to end up using these two different kinds in the Learn Guide that I'm writing. One really nice thing about these is there's this sort of standard-ish phone bank style that has a plug that goes up into your phone. This one's slightly broken, but that was originally a little lightning cable. And they have USB-C charging on the side there and a button for checking the status. That fits in this one perfectly. So I may end up using this to power a Sparkle Motion, wrap most of the interior in LEDs. That'll go in there, and then I'll maybe use a little 3D printed support so it stays put, and it'll be easy to just open up and charge.
Yeah, that's perfect.
For the interior. So that's the one style. However, they kind of discontinued them in the larger sizes, so I am going with that style I showed first, and I have my first completed one here.
Nice.
Which, this camera won't capture the LEDs too well, but you can see I've just got a bicolor blinking pattern going in here. I have 100 of our pebble style LEDs, the strands with these nice little epoxy pebbles that you can see. I have a battery pack, which is one of my favorite little slim battery packs in here. I have a Sparkle Motion that is in one of these. Oh, I just popped it open. It's in one of these little cases. So you don't see too much of that because it's mostly all white. And then I've added a little charging port back here so we can charge that from the outside. This one, since it doesn't have the trapdoor, I decided not to try to make my own. And instead, it is going to get shoe goo or E6000 glue to rebond this with clamps. Never to be opened, charging when you're not using it, and then since it's WLED, it's all done over. If I just hit my phone here, I think we're not in the same Wi-Fi zone as we were before, so it's a little slow to respond. But I can turn that on from the phone. I can change to different patterns and things like that.
Nice.
We'll get a nice effect. And then the thing I had been showing before is that the two are going to be synced together. So ESP32 is the basis of that Sparkle Motion. They can make a little network between the two, and you can tell one to drive and sync the other. They also have microphone built in, so they'll do sound reactive, frequency reactive, FFT stuff, and also motion reactive. But if we need to have like a playlist of patterns, then that'll just be programmed on one, and it'll tell the other what to do. So it should give us a really, really fun effect and something new in the world of platform shoes, I think.
Yeah, this is a great build. I love how the pebbles look in it, because it almost, you can't, like if you look at it quickly, you almost can't tell that they're individual LEDs, because it almost looks like the sparkly like sequin stuff. So
yeah,
really,
it's really nice. That was Lamore's suggestion. I was using some of these before that have like shapes, plastic shapes, parts and stuff, but you just don't get as many of them in there. And these, I think that huge number of LEDs in there all mushed together is a nice approach.
Yeah, it's awesome.
Back on, you just get this kind of wall of color. I think you could also do, depending on the shoe you had to work with, more of like a matrix, like a 2D matrix, maybe with strips, flexible strips, or even a flexible, and then run patterns and things. But I think this will look really nice, especially on like a glossy floor, just to see all that glow.
Yeah.
So that's my project. Now I'm going to be out of town for a couple days, so I won't be back to this until next Thursday. There won't be a John Parks workshop tomorrow, but I will be back with a couple shows next week. So tune back in for those and for some continued progress on this. And hopefully soon I'll get them over to Josh so we can get some real performance footage and nice photos of these in action.
Awesome. Looking forward to that. And we'll miss your show, but have a good trip.
Thanks so much.
All right. Have a good one.
Bye.
All right. That's awesome. Now we're going to hear from some folks in the community, starting off with Bradán. Hey, how are you?
Good. I apologize. For some reason, my OBS isn't working, so you don't get the nice splash screen that I normally start with. This is a little different. I've been working on a bunch of electronic projects, and a lot of them have existing PCBs. And what I was challenged with is I used to try to like solder a wire on if I had to debug something or if I was testing something. And that got really, really difficult. And I saw this design for these probes. And these are very, very sharp. But all they are is the little needles for cleaning the nozzles of a 3D printer.
Oh, okay. Yeah.
And so I found a design online. I really liked it, but I wanted to make sure that people could really do this and customize it the way they wanted. And so I wanted to expose all the possible files they wanted for this and have instructions on how to build it. So I redesigned all the parts. And so, for instance, this little arm right here, there's a vertical piece, a horizontal piece, this little finger, which adds a lot of flexibility to it. And then the needle itself. And I get into how to solder the wire on it. So what I wanted to show real quick is, here's an example. I've got a PCB here. And what I wanted to do was I needed to detect what was going on this one little LED down in the corner. And that was almost impossible the way I used to do it.
Yeah.
But with this jig, I can literally put these needles down on soldered pads that don't even have any access to them anymore. So a 0.5 millimeter pad you can hit really easily with one of these needles. And so this has got set up. I've got red and black for my power. And then I've got a probe on that LED, and then I got a probe back here, which is actually attached to the wake button. And so if I connect that one up, you'll see the little LEDs light up. Okay. And then up here, I'm actually looking at the serial data. And this allows me to stick, and it's got little sliders on it, and it's all 3D printed. Doesn't require any supports to print it. And it can be printed on almost any printer because I kept the size of this plate right here to 200 by 200. And I've used it for 3 or 4 different things just in the past month. And so the first one was I was trying to debug infrared on CircuitPython. And the problem I ran into was my timing was off. Well, it turned out that it was really easy for me to put a probe on the IR receiver side of it and then look at the scope and actually time out how long my pulses were. So that was like the very first thing I used this jig for.
Very cool.
And then another one I used with Adafruit IO was I wanted to find out how long a battery would last. And so I wrote a little Python script on a Raspberry Pi that would simply wake up the PCB, let it run for 30 seconds or so, take a voltage reading with the meter, and then upload that to Adafruit.io. And then it would just run. It ran for like 4 or 5 days until the battery completely died. And I was able to see how long the battery would last and what happened and at what point different parts of the board stopped working.
Nice, yeah.
And then this example right here, I was just trying to test out. This is actually an old board from 2021 I created. But it allows me to actually look at the data being created by any pin on it. And so I'll put the link in the chat. All the instructions for building this I've written up. It's in a GitHub repository. It's open source. And all the files, not only the STLs so people can print them directly, but also the step files and the original CAD files are up there. So if somebody wants to mix this or mod this, they can go right ahead and do that. It's all pretty easy. And it gets into what hardware needs to be done. But all the 3D printing doesn't require any support. So it's really easy to do on anything from an Ender 3 on up.
Nice. And I've seen, like, I know there's different, like, kind of little probe pegs out there, and I've heard that they can be kind of like hard to keep stable and stuff. So this looks like really secure. Like
what I love about this
is flop around.
Between the amount of flex you have in this and the amount of flex you have in this, it's real easy to place this. You can be off by quite a bit, and then I just take a pair of tweezers, grab the end of it, and I can just move it around to wherever I want it to be.
Nice.
Like that. You can see it's a lot of flex to it.
Yeah.
And so it's easy. You don't have to be directly on it. Just simply take your tweezers and place it, and then it's stable after that. And I really didn't think I was going to use it as much as I do to do some testing, diagnostics. I even used it when I wanted to add. This was something I showed a couple of weeks ago. I took a circuit playground blue fruit, and I wanted to add a charging circuit to it. Well, the problem was I had to figure out where on the existing PCB to add the charging circuit.
Right.
And Adafruit posted the schematic and the board layout, so I kind of had some ideas on where I thought I wanted to do it. But this jig allowed me to actually put pins right there and then see what happened when it was running off a battery or if it was plugged into USB. And I was able to determine very quickly where I wanted to put the charging circuit on that board. And so it's turned out to be much more interesting and useful than I thought it was going to be. And it was really easy to 3D print.
That's great.
I'll put a link. And I'll put a link out there for anybody who wants to look at the instructions and the print files.
Awesome. Thanks so much for bringing that by. I'm definitely curious about it. I'm always looking for different ways to be able to analyze things. So thank you. All right. Now we're going to have todbot play us out.
Oh, hey. Nice to see you, Liz.
Good to see you too.
So I've been working for the past, several months on a synthio tutorial.
Yes.
Sort of revisiting the synthio tricks idea, the page that I did a while back, but actually make it a little more structured. And in doing that, one of the end goals is to actually make a set of full synthesizer sort of voices or like devices. And one of them lately, I've been using this as a model, the Roland TB303.
Nice.
And so just a couple days ago, I recorded a little video that sort of showed how the progress so far is. So if you don't mind, I will show it off. So this is on a little Pico test synth board. This is the board that I've had for a while. I've had this one. This is the one that was root for the original Pico since like 2023. It just houses like Pico, an OLED display, an I2S DAC, a couple knobs, buttons, and then cap touch buttons. And then right before the tariffs back in February, I did a really quick one that allows you to use the RP 2350 on the Pico 2 with cap touch inputs. And so this is trying to put all of the functionality of a TB303's voice on just two knobs, which means the screen shows two parameters, and each the top row of buttons lets you choose which of those two parameters you're looking at. So if we start it going here, I'm adjusting the cutoff frequency now, and
we're not getting the audio in, I don't think.
Oh, no audio. Weird. I wonder why you're not getting the audio. Ah, that's too bad.
Can you hook up to is it a speaker or is it your
Yeah, I guess let me do the emergency change here.
Yeah, no worries.
It's strange because it's going through OBS, but let's see here. Survey says. How about that?
A little bit.
What's going on?
It's coming through a little bit, but you know, it's okay. We can make it to now. It's a little louder. Okay. So that's adjusting the filter, you said.
Sorry, what's that?
So that's adjusting the filter.
Yeah, yes. Sorry, it was so loud I couldn't actually
No, it's all good.
hear you in the microphone.
Okay.
But anyway, yeah, it's too bad. I tested this a couple times before going live, so I wonder what the difference is in the audio. Um, but anyway, the whole point is that this is just a technology demo running on this sort of spare board I had, and eventually maybe there'll be like something a little bit more synthesizer looking than this little test platform.
Yeah, that's cool. I like how you have the keys and the keyboard layout too. So it's like, yeah, nice. And then
All right.
what DAC are you using as the output?
Oh, this is the PCM 5102. I've been using these for several years. They're like really cheap, and I'm really happy that Adafruit makes a one with known good components now,
Yeah.
instead of the random ones you get off Alibaba or whatever. Who knows?
Yeah,
Who
the
knows
excited
what
when that
those
came into the shop. So if you want to drop a link in Discord to your synthio guide, I think that'd be great. And
Oh yeah, totally.
as it expands.
Yes, yes. Thank you. And yeah, if anybody wants to do synthio and have questions, please shoot them towards me.
Nice. All right. Thanks so much, todbot.
See ya.
Bye. All right. That was our show and tell for tonight. Thanks everyone who came by. In about 13 minutes from now, Ask an Engineer is going to be live right here. So you have time to go grab a snack and then get comfy for some good engineer talk. And until then, have a good night, folks. Bye.